look at the ground beneath you. Now, imagine it is the summer of 1945. The war in Europe has finally fallen silent, but for the people of Great Britain, the victory feels hollow as they stand in the center of their cities. The silence is not peaceful. It is heavy with the scent of pulverized lime, wet soot, and oxidized iron. Imagine that the floor of your brand new home is sitting directly on the very bricks that were blown apart by a Luftwaffe bomber just months ago. While the world celebrated the end of the conflict, British engineers were facing a different kind of combat. 220,000 homes were completely gone, and another 3.5 million houses were sagging, boarded up, and riddled with shrapnel. In London alone, 700 acres of the capital had been burnt down or pounded into a literal rubble heap. For the men returning from the front, there was no home to come back to. The workforce was aging, and for 5 long years, not a single apprentice had been trained in the building trades. There were no bricks, no timber, and certainly no time. Rebirth had to be industrial. Their solution was not just to clear the mess, it was to turn the ruins of the past into the bedrock of the future. This is the history of the hardcore estates. The scale of the catastrophe in 1945 was almost beyond comprehension. In cities like Birmingham, Liverpool, and Hull, the destruction was concentrated in the industrial core where the people lived. The government estimated that nearly 29% of the nation's pre-war housing stock had been impacted in some way. The term damaged was a cruel understatement. It included everything from homes that were simply uninhabitable to those that required immediate demolition. In the East End of London, the inability of local authorities to relocate the homeless caused a sense of abandonment and fury. The government had promised post-war compensation for furniture and clothing, eventually paying out billions in today's money. But you cannot live on a compensation check. You need a roof. The housing shortage wasn't just a logistical hurdle. It was a threat to the very stability of the post-war order. The man chosen to lead the logistical counteroffensive was Sir Norman Fenwick Warren Fisher. He was not a politician. He was a logistical titan. As the Special Commissioner for the London Civil Defence Region, he oversaw a workforce of 9,600 men, including seasoned veterans from the Royal Engineers and the Pioneer Corps. Their task was the clearance. This was dangerous, grueling work. During the Blitz itself, over 50 Pioneer Corps companies served in London, clearing debris and shoring up bomb-damaged structures. Over 100 Pioneer soldiers were killed or seriously wounded just trying to keep the roads open and rescue survivors from the wreckage. But once the bombs stopped falling, the mission shifted to massive-scale recovery. They performed a forensic salvage operation on the ruins. Steel, wood, lead, roofing slates, and even window hardware were stripped and sent back into the industrial maw of the war economy. Perhaps the most unusual salvage was the ash from 5,000 tons of tobacco burned in a warehouse strike, which workers recovered to be processed into nicotine-rich insecticide. Anything that remained the millions of tons of masonry, brick, and stone was transformed into hard. In engineering terms, hardcore is the layer of heavy, broken material used as a base for a load-bearing surface. The engineers used the ruins of the Blitz as a structural filler. By the war's end, Fisher's teams had removed 6.7 million tons of hardcore and nearly 4 million tons of debris from London alone. This material was processed using heavy-duty quarrying equipment. The Royal Engineers deployed specialized quarrying companies, equipped with 25 by 13-inch jawbreakers, massive crushing plants driven by 100-horsepower diesel engines. These machines, utilizing the principles of Eli Whitney Blake's 1858 design, worked by compressing stone between a fixed and reciprocating jaw. They were capable of producing 30 tons of dry macadam every hour. If you visit the Harrowbear Airfield near Plymouth today, you are walking on the pulverized remains of the 1941 Blitz, which was transported by rail specifically to be used as hardcore for runways and foundations. This same logic was applied to the new residential estates. The Rubble provided a stable, well-drained substrate that allowed for system building, a method that favored speed and semi-skilled labor over the traditional, slow crafts of the bricklaying trade. While the bombs were still falling in 1942, The wartime coalition government established the Burt Committee, officially known as the Interdepartmental Committee on House Construction, chaired by Sir George Burt. This group was tasked with finding materials and methods of construction that were efficient, economical, and fast. They realized that traditional building methods would fail under the weight of the crisis. To an engineer, the old way was a nightmare of inefficiency. Sir George Burt discovered that there were 374 different types of chimney cans in use across the United Kingdom. The committee's recommendations led to the Housing Temporary Accommodation Act of 1944. This legislation authorized £150 million to construct at least 300,000 temporary homes within 2 years. The strategy was to leverage now-idle munitions and aircraft factories, producing a house that could be built like a fighter plane. The most innovative and technically advanced result was the AIROHB-2, or the aluminum house. Developed by the Aircraft Industries Research Organization on Housing, it was the pinnacle of post-war engineering. At the end of the war, the UK had a massive surplus of scrap aluminum salvaged from destroyed military aircraft, over 100,000 tons of it. The era was designed to consume as much of this material as possible. Each 10-ton package for an AIROH house contained about 2 tons of aluminum, primarily a high-strength alloy called Hidu. The production line at the A.W. Hawksley factory in Gloucester was a marvel of industrial logistics, rolling out a complete house every 12 to 15 minutes. The assembly process was almost entirely mechanized. Wall frames were sprayed with hot bitumen and passed under a battery of cement pourers to be filled with an insulating layer of foamed slag concrete. These panels then moved through low-pressure steam drying ovens to reach full strength in 48 hours. The house was manufactured in 4 separate modules, each completely fitted out with curtains, glazing, and paint. On-site, a crane would lift the sections into position, and an assembly crew would bolt them together. In a May 1945 demonstration on a bombed site in London's Oxford Street, a crew erected an AIROH in just 4 hours. In Brighton, a team managed to do it in a staggering 41 minutes. The Archon MKV represented a different kind of engineering challenge. If the AIROH was a module, the Archon was a sophisticated kit. It consisted of exactly 2,500 individual components, supplied by 145 different manufacturers. Taylor Woodrow oversaw the production. But the heart of the Archon was its tubular steel frame, designed by the legendary engineer Ovi Arup. Arup's design featured 14 double RSA stanchions, forming a T-shape around the perimeter, connected by RSA perimeter beams and tubular steel. Every component had a specific mark number, such as Archon 621st, and the detailed 47-stage assembly manual ensured that the rotation of work across a site was maintained with clockwork precision. The order of erection was scientifically determined, starting with foundation steelwork, moving to gable peaks and roof trusses, and finally to the cladding. The Archon was clad in double skin-profiled asbestos cement sheets, which were affordable, durable, and fire-resistant, a critical consideration for the closely packed urban areas of post-war Britain. The internal layout of these prefabs was dictated by a rigid Ministry of Works standard, a minimum of 635 square feet and a maximum width of 7.5 feet to allow for road transport. But within those constraints, engineers managed to fit more modern luxury than most Britons had ever seen. The service unit was a factory-built core that placed the kitchen and bathroom plumbing back. It included a refrigerator, a built-in oven, and a back boiler that provided constant hot water and a rudimentary vented heating system. For families who had spent their lives with outdoor toilets and tin baths, moving into a prefab was a technological revolution. To furnish these homes, the government introduced the Utility Furniture Scheme in 1942, marked with the CC41 Tuchesis logo. This furniture was designed by experts like Gordon Russell and Herman Labase to be functional, durable, and minimalist, using scarce oak and plywood resources with maximum efficiency. The labor required to prepare the ground and erect these estates often came from an unlikely source: prisoners of war. In estates like the Excalibur in Lewisham or the Unisecco in Catford, German and Italian posts were the ones digging the trenches and constructing the drains. One former POW even contacted an Excalibur resident decades later to reminisce about building the very drains that still served the house. The largest single prefab estate in Britain was at Belle Vale in South Liverpool, where 1,159 B2 aluminum bungalows were constructed on former farmland. This estate became a tight-knit community, where children played in a central sunken garden that had once been a large pond. Similarly, in Hull, the Terran house made from precast concrete and wood, panels-filled sites in Hopewell Road and Marfley Lane, providing Aubert 2,000 units for the heavily bombed port city. However, the rapid engineering of the 1940s eventually revealed its expiration date. These homes were designed for a 10 to 15-year lifespan. Yet many lasted for the Airy and Orlet houses, which were intended to be permanent, began to fail by the 1980s. Sir Edwin Airy's design had utilized concrete columns reinforced with metal tubing recycled from the canvas tilt frames of military trucks. Over time, carbon dioxide from the air penetrated the porous concreta process called carbonation. It rusted the internal steel tubing, causing the concrete to crack and spall. This led to the Housing Defects Act of 1984, which designated many of these systems as structurally unsound and ineligible for standard mortgages unless repaired. But while the steel and concrete frames eventually fatigued, the concept of the Rubble foundation has found a second life in the 21st century. Today, history is repeating itself in Ukraine and Syria. Engineers at the University of Leeds and the University of Sheffield are developing Rubble as a material bank, RM, in Ukraine, where an estimated 1.4 billion tons of concrete debris from bombed buildings now chokes the landscape. Researchers are using pioneering technology to reverse process the wreckage. Modern machines use AI-enhanced robotic cleanup systems and infrared technology to sort 300 tons of rubble per hour, stripping out textiles, steel, and hazardous. This rubble is then crushed into recycled concrete, aggregate RCA. Research shows that this RCA can replace up to 50% of the raw materials in new concrete without significantly affecting its performance. In Syria, this technology is being used to rebuild infrastructure faster, cheaper, and more sustainably than traditional methods would allow. The transition from destruction to reconstruction required a fundamental shift in how we view waste. During the Blitz, the sheer volume of material was overwhelming, but the specialized pioneer units realized that every brick could be reused. They utilized mobile jaw crushers to process the masonry into aggregate. These crushing plants were the definitive building blocks of the reconstruction, shifting stone, crushing from manual labor and simple hammers to far more efficient mechanical processes. It was a dirty, loud, and dangerous process, but it was the only way to clear the path for the future. While the AI, ROH, and Archon models were the most famous, other systems, like the wimpy Nofine's house, pushed the boundaries of material science. Nofine's concrete refers to a mixture that omits sand and fine particles, using only 1/2 to 3/4 inch stone aggregate coated in cement slurry. This created a porous, honeycomb structure that provided natural insulation and allowed for rapid casting using reusable formwork. Over 300,000 of these dwellings were built, addressing the shortage of skilled bricklayers by using a method that required mostly unskilled labor. As we look back at the millions of tons of steel and wood salvaged by Sir Warren Fisher's men, we see more than just a cleanup operation. We see the birth of the modern welfare state, built on a foundation of recycled aggregates and industrial ingenuity. The 1944 Act committed £150 million to this cause, a sum that political opponents at the time called excessive. But to the families moving in, it was the New Jerusalem. They lived in homes that were factory fresh, delivered on the backs of Hawker Siddeley transport trucks, and bolted together on the graves of the old world. The failures of the later systems, like the Airy houses corroding military tubing, serve as a reminder that speed and recycling have their limits. Carbonation and chloride penetration are the enemies of reinforced concrete, and those early experiments eventually required massive remedial work. But the hardcore foundations themselves, The crushed bricks of the Blitz have never failed. They remain compacted and silent beneath the streets of London, Birmingham, and Hull. A testament to an era when engineers looked at a pile of ruins and saw a city waiting to be reborn. Modern conflict zones in the 21st century are now the new testing grounds for these old lessons. The work being done today in Ukraine is not just about cleaning up. It is about material passports and digital traceability. We are now using infrared technology and AI to sort through 4 billion tons of debris. Separating the hazardous asbestos from the viable concrete, this is the evolution of the Pioneer Core manual sorting piles. We are still clearing the path, still crushing the rubble, and still building for the peace. The British prefab was the prototype for a world that knows it cannot afford to throw anything away. It was a victory of the machine over the bomb, and of logic over chaos. In the end, the history of the hardcore estates is the history of a society that refused to be buried. It is a story for every man who has ever picked up a tool and realized that the most important part of any structure is the part you cannot see. The foundations were made of war, but the houses were made for peace. The technical specifications of these units were a matter of national security and public pride. The Ministry of Works did not just commission houses. They commissioned a new way of life. The Blitz Report No. 1 was the first of the post-war building studies, a series of technical papers that standardized everything from reinforced concrete structures to electrical installations. These reports continue to be cited 80 years later as the foundation of modern UK building regulations. They investigated how to make a house that was soundproof using acoustics, studies, and how to use non-ferrous metals like aluminum effectively. This was not a fly-by-night operation. It was a total mobilization of the scientific and industrial community. The Directorate of Post-War Building, established in 1941, coordinated this effort even as the outcome of the war was still uncertain. The impact on urban geography was profound. Prefabs were not just dropped into empty fields. They were surgical implants into the wounded anatomy of the city. In many cases, they occupied the bomb sites between existing Victorian terraces, creating a strange juxtaposition of old brick and new metal. In others, they took over the royal parks and open spaces, which had been exempt from development for centuries. The public eventually demanded their parks back, leading to the removal of many units by 1968, but the memory of those garden cities remained. The estates were designed with a sense of community, often arranged around a central green and connected by footpaths rather than roads, giving them the feel of a holiday village rather than a disaster relief camp. The durability of the Aero B2, despite its temporary label, is particularly made from hiduminima, material specifically developed for high-stress aero engine sit, was remarkably resistant to corrosion. The process of foamed slag insulation in the wall panels was also ahead of its time, providing thermal performance that exceeded many traditional brick homes of the era. The use of hot bitumen as a vapor barrier and adhesive was a standard industrial practice adapted from aircraft fuel tank production. These houses were effectively monocoque structures where the skin and the frame worked together to resist loads. Another lesson from the aircraft hangars of Gloucester and Weston-super. As we conclude this forensic look at Britain's post-war reconstruction, the lesson for every engineer and historian is clear. Resilience is not just about the strength of a material. It is about the ingenuity of the system. The men of 1945 did not have the luxury of choice. They had millions of tons of waste and millions of homeless citizens. They solved one problem with the other. They took the bricks of the Blitz and turned them into the bedrock of the 20th century. Next time you walk through an old industrial city, look for the level ground, the strange rows of concrete bungalows, and the hidden histories beneath the pavement. You are standing on the ruins of the Blitz, recycled for the peace. And for the men who built them and the families who lived in them, those prefabs weren't just temporary housing. They were the first victory of the post-war world, a testament to a nation that turned its destruction into its foundation.